In this lesson, we're going to be destroying a 3D scan because it wouldn't be a true MoGraph course if we didn't at least have one 3D scan in there, and this seemed like the proper place to insert it into our lesson plan. So we're going to be doing this destruction effect on this skeleton-like figure. Now, I'm going to we're going to be able to go over several topics in this lesson. One of them is going to be how to create glue constraints and how to break them. Also, it's going to be how to add these little drag forces in there to kind of create an explosion sequence that's kind of inspired by the waking up dream sequence from Inception, where Ellen Page and Leonardo DiCaprio are in a dream together talking in a cafe, and then as they're coming out of the dream, all the food trucks and newspaper stands and just general stuff around the street starts blowing up but then it undergoes this kind of dreamlike drag force that slows it down in midair, and then will release all those particles into normal gravity at the end of it. So we're going to cover how we can make interesting fractures that don't really look like they were done with Voronoi. We're going to use the Boolean fracture to kind of slice this geometry up. Then we're going to, glue it all together and just manage all the data that goes into a rigid body sim using Bullet. And we're going to we're going to work heavily with glue constraints and a little bit of the SOP solver as well. So, this is going to be kind of a lot going on in this lesson. If it doesn't all stick right away, don't worry about it. Really, I kind of wanted to just leave here a nice, fully polished lesson so that you could have a piece to refer back to if you're ever asked to do any sort of destruction job or anything like that in the future. This lesson's here for you to sort of kind of come back to and refer to, and also follow along with right now if you want to make something cool. So let's just get into it. In this section, we're going to be using 3D scan. I'm going to actually be using, if we scroll down here, I'm going to be using this kind of skeleton-looking decaying type thing. I believe it is called Le Transit de René de Chalon. I don't know if I got that right, but pardon my accent or French or what have you. But yeah, this is the one that you're going to want to download, and then we're going to load that into Houdini locally. Again, that's at 3D scans. I believe that these are public domain models, but just so we're on the same page, you can actually download this model yourself in case we're not able to distribute it with you with this project. So in Houdini now, I'm gonna be using my quad layout that I have selected, that I built earlier in the introduction section, and I'm just going to throw it on a file node, and we're going to read in that file. So let's dive inside. I'm going to select the file node, go up to this little paper icon, and I've already navigated to this folder on my hard drive, and we'll just hit accept. And in comes the big, gigantic 3D scan that is thousands of meters tall. Because the units are off in whatever software generated this, we're just going to translate it. So throw it on a transform. Oh, sorry, we're not going to translate it. We're going to scale it using a transform. So in the uniform scale, 0.001 to bring it down to size, and then I'll hit spacebar F over here, and you can see that it's about 2 meters-ish tall, which is pretty much the right size for the human body. But if you look really closely, it's pretty high res. We could probably work with this, but it would just slow things down, and to keep things a little bit snappier, what I'm going to do is just poly reduce it. So I'm going to throw it on a poly reduce. And I'm not sure, I believe this is probably the first time we're using this in this course, but the polyreduce is a great tool, and it exists in many applications in various forms, but it does exactly what you think, or what it says it does, which is it reduces the amount of polygons that you're going to use. So right here, I want to use, we've got a percentage of input polygon count. Here we're going to keep 100% by default. I'm actually going to bring this down to 10%. So it's going to sit here, you look down in the lower left-hand corner, it's going to be thinking about reducing the polygons a little bit, and then if you keep your eye over here, you can see now this is a much lower res much lower res mesh. Let's see, before, if I middle mouse, we had 990,000 polygons, and now we've got 99,000 polygons. So it's just a little bit more lightweight, and from the distance that we're going to be positioning our camera, at least for what I'm looking at, we're going to be looking sort of at the whole body for this. So really, it still looks quite high res from back here. So we're not missing those extra polygons at all. All right, so next, what we want to do is maybe we're going to actually be shattering this thing, and we want it to sort of like create this crumbling or destruction that is traveling along the arm. Maybe it goes across the neck, then maybe moves down here through the body and then down the legs to finish off the effect. So what I'll do is I'll actually just draw a curve, and we'll use this curve as our sort of basis for where everything is going to be occurring. So I'm going to just throw down a curve node like so, and if I select it, you can see I have this node selected, but my display flag's still on the polyreduce. We're going to actually use this now to actually draw on to our object. So if I have my curve selected like so, and making sure this is still visible, and I go to my manipulator over here, and I click it, I can now start drawing polygons, drawing curves. But if I use this snap to point, you can see that this kind of green, these green highlights appear around my geo, which is what we want. So that means that it's snapping to these points. If we get really close, you can see that it's every time I get near a point, it's trying to snap to it. So if I back out here, let's just kind of draw a nice curve that kind of wraps around this body. So maybe I'll start it right here at the crease of the elbow, and I'll kind of come down, and then maybe we'll go underneath the arm, around back here, over the shoulder, and then I'm just clicking with my left mouse button to place these points. We'll have it, actually I'm going to undo that last one so you can see I've got that point here. I'm going to maybe kind of come across the neck a little bit, and then come out over to this shoulder, and then I'll just come back down the middle, across the ribs, out to the right hand side, and then back over the pelvis, through the thigh. Maybe we'll wrap around the back here at this point. And then right here, we'll leap across to the other leg, come around this knee down like so, and maybe jump back to this leg and finish off down at the edge of the foot like that. So now once I've set all those points, I'm going to hit the enter key to just sort of lock it in, and you can see we've got this nice kind of curve that's wrapping around our character. I'm going to the next thing I'm going to do is let's smooth out this curve a little bit. So we have just like a few control points. If I show only if I set the display flag to the curve, you can see we've got like a bunch of little points that we just laid down. I'm going to just resample them using a resample node, and this will just increase the resolution of these points. If I show my points here, I can just decrease this length, and it'll decrease the length between the points like so. And then I'm going to go down here, and the next thing I want to do is actually I want to project this all these points back onto the geo, just to make sure they're on the surface of the geometry, because we're going to be using this to kind of carve out pieces of the geo, and if it doesn't perfectly line up, well, we can get it to kind of snap. Like you can see it's kind of going inside the arm right here. If I turn this on, you can see that it's kind of dipping below the surface a little bit in some places, and by resampling and increasing that point count, we'll have a lot of points that we can actually push around and get them to stick to the surface. In fact, I might even just increase this resample a little bit higher by decreasing the length to something like 0.01. So lots of points. I might also go down here and say to use subdivision curves. That just kind of smooths everything out a little bit. Instead of using straight lines where it's interpolating equal segments between the points, it also tries to smooth it if you put on these subdivision curves. Cool. So the next thing I want to do is I want to ray this back onto the geo to make sure it's sticking to the surface. So let's throw down a ray sop. Ray basically will just take this left input geometry, and it'll project it to the closest point on the surface of the second input. So we'll just wire this in like so, and I'm going to turn off the point display. And you can see the ray's got some guide geometry that is blue. See if yeah, it's got guide geometry. I'm just going to turn that off. And you can see that this ray is kind of it's kind of projecting all over the place. That's because it needs to be set to minimum distance. So that just means it's going to move the curve the minimum amount of distance that it will take for it to be sticking onto the surface of whatever object's coming in to this second port right here. You can see it says collision primitive down here when it gives us a little hint on that. So that's now on the surface. Now, if I kind of template the old curve and the new curve, you can kind of see that it has moved it slightly. It's a little bit. It's not quite as smooth anymore. So I might just add another smooth after this. Not entirely necessary, but why not? Just to smooth out that final curve that's been rayed back onto our original geo. So now let's use this curve to kind of create a sweep that we can carve out of our original mesh. So what I want to do is maybe we can throw down a polywire. We'll use this polywire as the basis to kind of cut out a region of higher detail that we want to destroy on our geo. So I'm going to just increase the number of divisions to something quite high, like 10. That looks pretty good. Then I can bring the wire radius down and have that be sort of kind of our guide as to like how large of a chunk this is going to carve out of our geo. But the problem here is that this wire radius is completely uniform, and I would love for it to maybe be a little bit thinner up here, but then get kind of thick as we're moving through the torso, and then maybe thin off a little bit for the leg, but then get really thick towards the bottom, just to make sure we engulf all of this stuff so that we actually have the whole statue falling over by the time we get to the end of sweeping on this geometry that we're gonna destroy. So let's actually throw down a point wrangle, or sorry, a point VOP. I'm going to put that in before the polywire. I'm going to just jump inside. And here we could use something like p-scale to drive the width of this curve. Now, we need to sort of establish a value that runs along this curve that runs from 0 to 1. And right now we don't have a value for that. But thankfully, the resample will generate exactly this attribute for us. If I go back to the resample and I just click this curve U attribute, this will create this curve U right here that runs from, in our geometry spreadsheet, you can see under points that it runs from 0 all the way up to 1. So points that are at the beginning of the curve are going to have a value of 0, and then they're going to go up to 1, which means that a value of 0 to 1 we can feed into a ramp parameter and totally get some and get exactly the sort of profile control that we're looking for. So I'm going to go back into the point VOP, and now that we have that attribute, I'm going to bind it in. So we're going to throw down a bind to import that into our VOPnet, and I'm going to name the parm the curve U attribute that we just created. Now, if I just bind this out to p-scale, so I need to bind export rather. It looks like we're not actually going to need these globals for this section, so I'm just going to kind of move them out of the way. If I just wire curve U into p-scale, we can see what that does. So let's just bring curve U right there into p-scale, and then if I go and highlight this and then highlight the polywire, nothing's happening. But if I go over to the wire radius and I just type in at p-scale to look up the attribute that we just created, you can see that it's kind of hard to see, but it starts pretty thin and then it gets really big towards the end. But it's just a little bit too extreme right now for us to really even notice what's going on. So we'll just go and dial that in our point VOP. So here we'll create a let's create a ramp parameter. And we're going to want a spline ramp, not a color ramp. So we'll do spline like so. And then we'll wire that in. And now if I hop back up to the top level of our point VOP, you can see our ramp looks like nothing. But if I just like set a point in the middle and just bring it up a little ways, doesn't take much right now. You can see that we kind of get this. I'm just going to turn off the template here. You can see we get this shape that kind of starts really sharp, grows fatter in the middle, and then kind of thins out again at the end. And that's what this little tiny amount of value that I've added here will do for us. Now, this is really hard to work with in this way. If I grab this and bring it up, it just gets out of control. And I really like to have, the largest parts of my ramp be at maximum. So I can just adjust what this maximum value is by remapping it using that range mapper like feature in here called a fit range. So fit range, I know that my ramp is going to generate a value between 0 and 1, so I don't need to do anything with the source minimum and maximum because those are already set correctly. I can just change my destination minimum and maximum values. And in fact, what I'll do is promote these parameters so I can adjust them out in SOPs. So I'm just going to middle mouse click on destination minimum, say promote parameter, and middle mouse on destination maximum and say promote parameter. So now I can go up here and scroll down here and I can say I want my maximum output to be 0.1. So a value that is only 0.1 wide. And then I could say I want my minimum value. I don't need it to go all the way to 0. Maybe I just need it to go to 0.02, something like that. Because this should generate some reasonably interesting cutting geometry when we cut the pieces out of our geometry that we want to be high res. Basically, what we're going to do is use this section to bool off a higher res fracture, and then the rest of it will be sort of a lower res fracture. Cool. Now I think I want to add just a little bit of noise to this. So I want an even higher res mesh around the radius. So I'm going to just take this poly wire and maybe just add some more divisions here. So maybe something like 30, so that when I add a noise to it, it will look all gnarled up and stuff like that. That'll help create a more interesting fracture where the high res interior pieces meet the the higher fracture density meets the lower fracture density. It will have not just this smooth line, but we can add some noise of our own. So let's throw it on a mountain. And if I throw this in here, the mountain's default settings are way too high. So I can just bring this down a little bit. Let's bring the height down and maybe the element size down a little bit. I'll bring this element size down to maybe something like 0.01, and then the height is a little bit aggressive, so I'll bring that down to maybe a 0.07. That's starting to look pretty cool, but I feel like I could get even higher res with this. So instead of going all out with trying to add more points to the resample and stuff like that, I'll do it I oftentimes do, which is I'm just going to turn this into a VDB and then convert it back. That helps me kind of up-res things. And you can see there's also like some overlapping going on right here where it's kind of twisting back in on itself, and converting it to a VDB will kind of help clean some of that up too. So let's just do a VDB from polygons. And let's choose a voxel size. Let's just bring this down to something like 0.0. Let's do 0.002. So that looks pretty good. And maybe I'll smooth it off a little bit. So let's turn on a VDB smooth SDF. This helps. This is going to help get. You can see that it's sort of some of those polyfaces are kind of showing up. The smooth will help get rid of some of that. So I'm just going to put that in there, and maybe I'll bring the filter voxel radius up to something like 2, maybe even 3. Yeah, that really kind of just smooths things off. Then I'll just do another convert VDB. Actually, not another convert VDB, just the first convert VDB. And then I'm just going to turn this back into polygons by going here and saying polygons, choosing polygons here. So we get sort of we've up-resed now from this polywire to this, and it's pretty fast to calculate. So now when I throw the mountain in there, we get a much more cragglier looking look, given the resolution that we've provided. So again, if I like bypass all these, you can see before kind of a low res craggly look, but after much more craggly looking for sure. And, you know, from here, I could continue to mess around with, you know, the roughness to get this to look even sharper or less sharp if I wanted to. But I'm pretty close to the values that I set when I was building this example. So I'm going to just stick with it. So the next thing I'm going to do is I'm going to actually bool this section out of our original geometry. So let's throw it on a Boolean. And let's bring in our reduced statue. And then in the second input, I will wire in the mountain. So it's going to think about it for a second, resolving intersections, blah blah blah. It looks like it hasn't really done anything. So sometimes there's issues that go along with you know, Booleans, and you kind of gotta debug them a little bit. So I think that what I would do to sort of fix this, let's just try using a subtract operation, and I'm seeing that it doesn't look like much is happening there. It's actually making everything sort of disappear and kind of glitch out. So what I'm going to do is after my mountain, I'm actually let's see, if you look really closely at like sort of the end right here, you can see that there's some sections that are sort of folding in on themselves, and you know, when we added this noise, it might have created some stuff that is a little bit hard for the Boolean to actually calculate. So what I would do at this point is I'm actually going to convert this to a VDB and back one more time. And that just sort of helps smooth out any kind of little kinks like this that might make it hard for the Boolean to understand what is going on with the geometry. So let's just do another, actually what I'll do is I'll just grab this VDB from polygons and the convert VDB right here. And I'm just going to hold down the Alt key and drag them off to the side to copy them. I'll hold down the Y key to slice those guys off, and then I'll bring them down below the mountain. And we'll just wire those back up like so. So now it is converted to a VDB and back, and you can see that if I go up to this area where there was an issue before, if I look at the mountain previously, we've got this like kind of kink in there, and just converting it to a VDB and back kind of irons everything out, but still maintains a lot of that detail. So now let's try wiring this into the Boolean. And I'll highlight that. Now you can see that it has successfully carved out that chunk from our statue. So cool. So this will sort of serve over here. This subtracted version will serve as the sort of the piece that will shatter. That will kind of be like more. These will be larger chunks, and then I want like smaller shards to fill in this area on the inside. So let's just fracture these larger chunks on this geometry right now. The way we're going to do that is we're going to use the Boolean shatter. Now, there's like a whole bunch of different ways of creating fractured geometry in Houdini, but I find that with a geometry that's a little bit that's a little bit more complicated like this, it works better for me to use lower level tools. I could try to use RBD material fracture, but when I was setting up this lesson, there was still some kind of issues that occurred, and it was a little bit harder for me to debug. So for example, RBD material fracture. If you don't remember from a much earlier lesson, we built a sort of a debris generator. This RBD material fracture was sort of at the beginning of that. It was the basis of that. And it's sort of a very powerful but artist-friendly tool that allows you to create different things like concrete, glass, or wood fractures. When trying to use the concrete fracture, I was getting some issues with it. Now, I feel like if you want to give it a go, by all means, try using the RBD material fracture. It's super powerful. But what I want to do is just kind of get in there and do what RBD material fracture is doing in a much lower level. Like if we dive inside the RBD material fracture, it's got this gigantic it has this gigantic network that it builds out for doing all this fracturing, creating constraints, and all this other stuff. And I just feel like for this example, we don't need all of this. We can actually just kind of roll our own and kind of do it a little bit like the old school way. So I'm going to actually just use the Boolean shatter. Or sorry, it's called Boolean fracture. And so Boolean fracture is just a lot like Voronoi. It takes in geometry, and it takes in, instead of points for creating Voronoi cells, it creates cutting surfaces. It asks for cutting surfaces that are going to slice this object up into a bunch of different pieces. So what we need to do is provide those points, and we can do that by scattering some points across this geo. So let's throw down a scatter. Or rather, we need to provide the cutting planes by scattering points and then instancing our cutting planes onto those points. So let's throw down a scatter. And I'm just going to scatter a low number of points, like 30, onto our geo. And I'm just going to hit the D key and turn up the point size so that it's a little bit more visible. So you can see I've got 30 pieces here. I'm just going to turn off relaxation iterations just so they aren't so pushed away from one another. And then I'm going to throw down an attribute randomize. The attribute randomize is going to allow us to sort of adjust the normals of our geometry so that they're all pointing in different directions. So if I, instead of having this set to color, I'm just going to set it to N. And then if I throw down a grid and a copy to points, and I copy the grid onto these points, I'm going to make the grid a little bit smaller. We'll start with the size of maybe 3 by 3. You can see the grids are all kind of facing in different directions. If I didn't use this attribute randomize, because it's looking at the normal and then transforming this plane based off of the normal, with no normals, it just copies this grid onto those points with no orientation information transferred over. So I'm just going to turn this attribute randomize back on, and then we're going to just randomize this in a different way because all these planes are sort of kind of facing in this like kind of diagonal like way. That's because it's this setting of uniform continuous is not what we want. We actually want to randomize inside of a sphere. You can see now that the distribution of these grids is much more random in terms of its rotation. So the other thing I want to do is instead of if we were to like use this in our Boolean fracture right now, this would just generate a bunch of straight cuts. And I actually want to have more of a craggly kind of cut like we have up here, where these borders where we had booled out that other piece of geometry that we created really kind of creates this sort of like gnarled up jagged edge type of a scenario. So I can add some interest to that by throwing down some additional resolution on our grid. So let's go to our grid, and I'll just crank up the rows and columns to, let's see, something like, let's do 300 by 300. So we've got a super high res grid, and then I'll throw down a mountain. Another mountain for sure. And on that mountain, let's do it's by default set up to do hybrid terrain. I just want to use the standard fractal, which is, it just makes it a little bit more I don't know, random seeming for my purposes. So we'll do that. Maybe I'll just jack up the roughness a little bit to maybe like 0.6 or something like that. And then in general, it's just a little bit too high. So let's bring the height back down to something like, let's try something like that. And let's bring the element size down to maybe something like 0.32. And the height down just a little bit more. So now we've got this sort of jagged surface that we can use to cut all of our pieces. So bring that into, now copying all those grids onto our points, we get all this madness, and we can plug this now into our Boolean fracture. So let's just drag these guys off to the side. And you can see right here on the left, it's looking for the geometry to fracture. So we'll just wire that into our Boolean that we created earlier. And then we'll we'll just grab this copy to points and wire it into the second input, and then I'll hit the display flag here, and it'll take a couple seconds to think about it. You can see down in the lower left-hand corner, it's thinking about performing a constructive Boolean operation, resolving intersections, finding non-trivial crossings, whatever that means. And it'll just take a moment. You know, doing this stuff, what I usually tend to do is, like, once I get a fracture that I like, I'll cache it so that every little tweak I make, I don't have to wait for things to run through this process. It can take quite a while sometimes. Generating cells, we're pretty close to the end when it starts saying generating cells, and there we go. So we have shattered now successfully our geometry. It still looks like it's all put together nicely. If you look really closely, you can see some cuts, but what I do at this point usually, just to judge what I've done, is I will throw down an exploded view. And you can see here that we have generated some really gnarly looking pieces. They've got nice edges. They don't look too uniform. The sizes all vary quite a bit, which is good. I like it. One thing I'm not quite liking is how this hand is appearing right here. When this all comes crumbling down, we've got this gigantic continuous piece here, and I actually want this arm to, like, really kind of fall apart, and I don't find that this looks realistic to me at all. If this arm is going to hit the ground and shatter, we're not going to get, like, a long piece that shatters this way. We're actually going to want it to be shattered sort of, you know, horizontally through the wrist, like so. So what I might do at this point, and yeah, looking at the rest of the geometry, I'm not seeing anything else that's too offensive. I just think that really this piece needs a little bit of love. So what I would do is maybe go back to my scatter. I'm going to take a look at it, and I'm going to take a look at it in context with my original Boolean geo. So I'm going to template the Boolean geo and then look at the shatter, and you can see there really aren't that many points up here. I could try and concentrate some more points up here by maybe scattering a couple points up in this direction, which I might do. Let's see what we can do here. Let's see if I just want to try and see if relaxing iterations brings those up a little bit at all. And it doesn't look like it does too much in that regard. I think maybe what I'll do is just add a couple points by hand to this hand up here. So let's just let's go and do I'm just gonna do another let's see, how do I want to do this? I'm gonna just let's just grab these points using a delete. So coming out of our Boolean, we've got this delete. I can select to delete points. And I just want to use a bounding volume. We're going to use a bounding box. And if I just grab this manipulator over here, selecting my delete, and bring this up to isolate near the hand, like so. And I'm just going to bring the floor up, just grabbing these red handles to bring the bounds of this selection box into the right sort of frame that I'm after. Bring this down like so, and we're still cutting out part of the face, which I don't want, so I'm going to bring this over. Yeah, if I go into my ortho views, so I'm hitting spacebar 3 to view it from the front, I can really kind of dial in this box. So I'll have it go, yeah, right here. I just want to scatter right in this region, so I'm just sort of creating a nice little region of interest for myself. And if I go back and hit spacebar 1, and I'm just going to choose delete, instead of deleting selected, I'm going to choose delete non-selected. So there we go. Now what I can do is I can scatter maybe only 3 points here, but I know that they'll be concentrated around this limb. So that's way too many points. That would take hours to calculate maybe. Not quite sure. Don't want to find out. So I'll do something like 4, and then I'm going to turn off the relax iterations. You can see that that kind of gives us a bunch of cutting planes that go right through the arm, and chances are that they will be pretty, that it should cut this geo up a little bit more more pleasantly for us. And to compensate for that, I'm just going to subtract 4 off this one. So we're just going to take from 30 down to 26. So we're only still doing a total scatter of 30 points. So now what I do at this point is let's just merge these two scatters together. So I'm just going to throw down a merge, so that leading into our attribute randomize here, we get both sets. We get the original set that we scattered and this new set. So just a little way to art direct your fractures. You have absolute control over where these. I could even go in and place the points literally by hand if I wanted to, using an add stop, just dragging them into position. But I like using the scatter when possible. I don't like doing that much work by hand. Do enough of that over here in the network editor. So let's see what we get now. I'm gonna just highlight our exploded view and wait for this to cook through. All right, and we're back, and it looks like we've got some really great fracture pattern up here now by this hand. I think that in general, this is all gonna look great. Cool. So now, now that I'm looking at it, I think that, once we get to the bottom actually here, I'm not going to want to actually calculate the fracturing on all these pieces though either. This is actually a section that I actually want the base to remain locked when we're doing our simulation. So actually I'm going to do the same trick that we did over here with this delete. I'm going to do it down here by the feet because I don't need to scatter extra pieces, extra planes down there. If we look at our scatter, it looks like there's a whole bunch of planes that are actually making it down there, which I don't necessarily want. So let's just grab this delete. I'm just going to Option or Alt drag it over and just wire it into this channel, or into this wire here. And then I'm going to just bring it down so that it is, hit spacebar 3. I'm going to bring it down so that it's framing up our feet section. So let's grab the feet section. And this is actually deleting non-selected. So basically it's cropping it into this region. Hit spacebar 1, go back. You can see all of our points are being scattered down here. And I actually want to drag the back of this out a little bit so it's fully encompassing the bottom of this statue. And I actually want to use just delete selected. So now we're only going to scatter up here. So we've got this, now we've got all of our scatter occurring just on the part of the body that we're really focusing on destroying. So good. I think that that's good now. Judging also from this, the previous fracture, it looked like we actually had a lot of really tiny pieces. And I think I'm going to just try my luck and dial this down just a little bit more on the force total count. I'm going to bring it down to maybe 20, just so that we don't have quite so many cutting planes. Maybe it'll make things perform a little bit better. We'll see. So I'm just going to let the Boolean do its thing, and we'll check out what we got now. So this is a lot of what it takes to prepare a sim. Most of the effort I feel like with simulation is, well, not most of it, but a lot of the effort with a good simulation is in how you prep your geometry for it. So it's good to just kind of take your time with these things and get it right and get close enough, because you're probably going to end up coming back and changing things later anyways. Cool. So yeah, down here, I'm feeling like we got a good amount of geometry, not too much concavity, which we'll deal with later. Like this section right here, we've got a section that like kind of wraps around and has this like sort of inner circle thing here. We'll deal with that. I'm fine with leaving it the way it is right now, but in terms of creating our collision hulls, we'll have to do a convex decomposition, which is pretty easy using the new nodes, and so that should be good. The skull is looking cool. Like the face might actually stay intact if once it falls down and shatters, and look, the arm looks great. So we're good with that part for now. So the only other thing that we would need to do in order to prepare our geometry, well, there's quite a few more things we need to do, but the next order of business, I would say, would be to generate these higher res fractures that's going to be going through this part. So to get that, I'm just going to copy this Boolean off by alt dragging it to the right. And over here, we're going to start building a stream that is going to deal with the inverse of what we just did. So where here we had the outside piece, now we're going to use the intersect. So instead of subtracting this shape that we created away from it, we're going to take out what's inside of it. So we're going to use the intersect function for that. And there we go. You can see that now we have the other piece of our geo. So if I kind of template this, maybe I'll actually, let's see if I throw it on a null. And I'm just going to wire these three things into that null like so. And we'll call this our large chunk base. And I'm just going to grab all these nodes by shift selecting and selecting them with the box picker. And then this one will be, I'm just going to grab this node and option drag it over here. And I'm going to call this small chunk base. So now if I template this, you can see that those pieces fit directly inside of the large chunk base. So now we can do just something similar to what we did here, which is just scatter more points and fracture it. So to do that, what I think I'll do is I'm going to actually, let's just copy the scatter. I'm going to copy the grid, the mountain, the copy to points, and the attribute randomize. So I've shift selected all of these nodes. You can see them highlighted in yellow. The scatter, grid, mountain, copy to points, attribute randomize. And I will just hold down the Alt key or the Option key and drag them over here. And now I've got my small chunk base that I can use as the, I can just rewire this up. So small chunk base will go into the scatter. That scatter will go into the attribute randomize. So now we got that randomization here. I'm going to actually turn off relax iterations on the scatter and increase the point count to like 50. So we're going to get many more fractures over here. I think that I actually, because I'm looking at the distribution that we have right now on our geo, I might turn on relaxation iterations, but not quite so high. So I'm just going to reduce the relaxation iterations to something like maybe 2. That's looking like it's not so evenly distributed, but not unevenly distributed either. So something like that looks pretty good. I may want to concentrate more points right here. It looks like this area is a little bit stark. So I could just go through and kind of try different seeds out until I get a value that like fills that area in. A lot of times, because the seed is very touchy, I like to scroll integer values, because I know I can, once I see something I like, I can go back to it, whereas it's really hard to kind of dial back to a float value or a decimal just by dragging the slider. So something like this is looking pretty good to me. I got like, it looks like I've got a pretty decent number of points and going throughout this. So we'll just go with this for right now, and if we need to add more, we can always do that later. So I've copied this grid that we've done the mountain thing to. I might just use a slightly smaller grid for this, just because it's not that large. Now, I used a 3x3 grid earlier because I generally want the size of the grid to be larger than the actual geometry. Just by a little bit, because if it's twisted and the geometry or the cutting plane doesn't fully cut through the geometry, it will actually create sort of, it just kind of has an error that occurs. And if it shows up, one of the ways to fix that, you'll kind of see planes just appearing when you'd think there would be a shatter, just sort of gets messed up. One of the ways to remedy that is to just kind of tweak some values, change the size of your grid, maybe adjust some settings on your mountain or whatever, to see if it kind of jostles something loose. But at any rate, for this one, I'm going to just dial the size down and take my chances with something a little bit smaller. let's say 2 by 2. I'm going to decrease the rows to maybe 200 by 200 on this one, just because we don't need quite all that resolution. And maybe I'll also bring the mountain down in height a little bit, something like that. And then maybe increase the roughness, like so. And I'll just copy this to points. And now that I'm looking at this, I think that I really actually do want to increase the height of this mountain a little bit. So now I'm looking at this. This is actually pretty flat, but when the mountain varies in height a little bit more, you get like the planes will re-intersect other planes and end up generating more tiny particles in chunks. So I'm actually going to increase that height up a little bit. Let's go to something like around 0.4. And maybe I'll just bring the roughness down a little bit. So we'll use something a little bit jagged like that and see what we get. I'm copying this to points. So there's all of our crazy cutting geometry. And now I'll just use another Boolean fracture. So I'm going to thread on a Boolean fracture. And into the left input is going to be the small chunk base. So bring these guys off to the side, and then I'll bring in these cutting planes and click the display flag and be ready to wait. It took a couple minutes, but now if I go and back over here and grab this exploded view and wire it in to our new fracture, you can see that we get all these little tiny pieces everywhere, which is great. That's what we're after. So a bunch of little pieces we can use to form some sort of disintegration effect. Sweet. So now I think that it's a good time to kind of cache this out. These steps both take the computer quite a bit of time to think about. So let's just break them out into groups and then save them out to disk. So let's run on a group. And we're going to group, let's just group this set of points first. And we're going to call this our small chunks. And we'll make another one for call this one the big chunks. And wire that in over here, and then let's just merge these two together. I'm tapping the escape key so that it stops cooking that, because I'm just going to wait for it to cook when I hit the file cache. Like doing all this work over here, the memories seem to kind of flush on this one over here. So I'm just going to merge these two together. I'm going to maybe just switch this to manual mode down here in the lower right hand corner so I can work on my network without it trying to cook on me, without me asking it to. And so I've got this merge here, then I'll throw it on a file cache. And this file cache, we don't want to do the entire frame range. We actually just want to do the current frame. And I don't actually want my geo named after the current frame, which is what this little $F is up in our geometry file path. So I'm just going to delete it. So we're going to go and create our chunks in the hip/geo. And then, so it's going to create a folder called geo, which is fine. And then it's going to create our cache file for this. I actually want to I just want to put this geo into another folder that is relevant to what this is, the $OS. So I'm going to just call this fracture pieces, like so. And so it's going to take that $OS right here, which is fracture pieces. And I'm going to actually make another folder just to throw this in there. So even though it's only writing out one file, I kind of like to throw it inside of a folder. And then we'll have $hip name $os.bgeo.sc. So if we end up creating a new version of the file and moving forward and need to save out new pieces, we just increment our file name, save it, and then it'll automatically save it as a new hip file inside of this fracture pieces folder that we're going to create in our right next to our project file, which is the $hip. So I'm going to just hit save to disk, and it's going to think about it. It's going to do that other Boolean shatter and then combine the two together. into our directory here. And if I go to my project directory here, you can see it's created a geo folder. It's created a folder with our fracture pieces in it. And here is our fracture geo. 31 megs. Sweet. Now I'll just click load from disk, and it will always load this from the disk for us. All right. So now my view is out of date because I had the update mode set to manual. I'm going to turn that back onto auto update. You can see we've got all of our fracture pieces right here, and I can do an exploded view down here now. So I'm just going to grab this guy, hold down Y, and oops, did not mean to cut both those wires. Hold down Y and cut off our exploded view, bring it down here. I'm going to turn off this template flag up there. I don't want that. And then we can see all of our pieces exploded in all of their glory, and we'll be working with this as our main fracture geometry when we go and set up our sim. So there's a couple other orders of business that I want to take care of, and that is talking about how we're going to manage all this data, because a lot of these pieces are pretty high res. Some of them have concavity like we were talking about before, and we need to we are sort of responsible for dealing with that kind of stuff. And it seems a little bit it seems like a tall order, but you know, you do this a couple times and it's really not that bad. I think, you know, we'll kind of go through this course, this lesson, and this lesson might be, you know, it might seem like there's a lot involved, and there is for sure, but you just got to kind of absorb what you can and come back through it and keep re-referencing it. You'll eventually get everything. So we're going to now use, so in order to name our pieces, now if we middle mouse click here, you can see that it has created a primitive attribute name for us. But that name, if I just go back onto manual mode, if I select this Boolean fracture over here, this Boolean fracture is actually generating a name for us, this name prefix. So if I go over here and look at the geometry spreadsheet, you can see that I've got pieces 0 to 2349 are all being generated by this Boolean fracture. Over here, it's going to be the same story. There's a whole bunch of pieces, piece 0 to 369 are being generated by this Boolean fracture. Now that we've merged the two together, that kind of creates an issue. If I were to say select, let's go to, if I go back here and say I want to blast a piece away. So if I blast, let's say piece 0, so I'm going to go up here, I'm going to select piece 0. So it's saying blast anything whose name is piece 0, and say delete non-selected, and hit spacebar F to frame that up. And I'm just going to switch this back to auto update. You can see that there is more than one piece here. That's because there was a piece 0 generated by the Boolean fracture for the large chunks, and also a piece 0 being generated by the Boolean fracture for the small chunks. And so it is named two separate chunks exactly the same. Same goes for piece 1, all the way probably up until, well, yeah, you can see piece 1 is part of the hand, and then something else down here. This isn't what we want. So what we can do is we can just rename all these pieces at this point. So if I throw it on an assemble, like so, and I tell it to generate a name attribute, it's basically going to redo this whole naming operation thing for us. So now if I go to blast, now we only have one piece for the hand. And if we go over here and look at our name attributes here, right after the assemble, we go from piece 0 all the way up to piece 2719. So it's now effectively renamed all of our pieces of geometry that we want to stick together as a coherent chunk. So everything should be good in that regard now. So it's just a little weird thing to get used to with when you send this into Bullet, it wants all these pieces to have their own names. If I didn't rename these pieces to accordingly, then Bullet would actually have had that part of the hand stuck to a part of the foot, and it would look like there were these invisible links linking these pieces of geo together, and it's not what we want at all. So the assemble, very handy. Now the assemble can do a bunch of other things like creating packed geo like we've explored in earlier parts of this lesson, but we'll actually do that later. At this point, we want to keep our geo unpacked because we're going to do a poly reduction operation on it to get it even more efficient so that it sims as fast as it can. So right now that we have these pieces, what I'll do is I'll throw down I'll just throw down a null to make note of the fact that this is high res geo. So we'll call this high res, like so. And then the next thing I want to do is let's do this poly reduction. So I'm going to go and, well, actually what I'm going to do before I do the poly reduction is I want to do a bit of convex decomposition. So I'm going to, let's just throw down a split for the time being. I'm not going to use this split in the end, but I just want to split off so that I can see everything in my big chunks group. So I've got all these big chunks, and I want to, I know that I had this, if I look at my exploded view here, I had like this piece right here, these couple pieces in the middle where they're concave. I want geo to be able to pass through. Now, it's likely that this might not matter, but just for the sake of being like kind of complete about it, I'm going to throw down a convex decomposition here. So this is kind of like what we did in our first example in the rigids section, which was to, kind of illustrate what these convex hulls are. So by default, this is what our sim geo would look like unless we brought this convex decomposition concavity value down. Now, this max concavity of 1, I basically think that means nothing. It doesn't look like it's decomposed any of our pieces. Mainly looking at like these ones in the middle where they're like kind of C-shaped. It looks like it's just shrink wrapped that piece. So I'm going to just go over here in this max concavity. I'm just going to start dialing this down and trying different values until I start to see more pieces showing up here. And in fact, to make this a little bit faster, what I might do is go back to the split, or to the exploded view. I just want to grab and focus on decomposing this one piece, and then I'll apply that to all the other pieces. So I'm going to use my, I'm going to hit my selection tool, and by default, it's selecting primitives, just selecting all of them. But if I select by name attribute, because all these pieces have names and it belongs to a piece, I can actually select all that geo right now, and then I'll just hit the delete key to delete it away. And that throws down a blast node, and I'll just choose delete non-selected. So I can just focus on this one piece and decomposing this one piece for right now. So let's go to our convex decomposition. I'm just going to dial this back down a little bit. You can see that it's starting to break it apart into separate chunks. Now I dragged this down to 0, which is probably a bad idea, so I'm going to rapidly hit the escape key. And even this, so like that allows you to kind of escape out of it doing some wild cook that you're not hoping for. So I will just let's just set this to a value of 0.05 and see what that gets us. Okay, it gets us these two chunks. That's pretty close to the C shape. I want to see if we can get a little bit closer though. Let's maybe try 0.04. And so you can see like it's really starting to form that C shape for us. Maybe even let's try 0.03. And I'm liking that. So I'll go with that and say let's apply this convex decomposition to all of our larger chunks. So I'm just going to turn off this blast. It's going to think about it for a second, evaluate the concavity of all these things, and then we should end up with a convex decomposition of all of our collision geos. So this is going to work much better over in the bullet solver and look more realistic. Not sure if it's actually going to make a difference at the end of it because we've got so many pieces it might be hard to tell, but just to be safe, why not? Cool. So now that I've done that, I don't really necessarily need this split. In fact, I want to keep everything in one stream. So instead of working on this split off geo, I can actually just specify the group over here. I don't want to do a convex decomposition for all those tiny pieces. I just want to do it for my big chunks. So if I set this to the group big chunks, it's going to evaluate all this stuff. I'm going to stop it because it's going to have to reevaluate it anyway. So I'm just tapping that escape key, and let's just wire in the high res directly to this this geo. So now we should see all of our geometry except for the this interior piece, like here, being decomposed like so. So you get kind of this mixture of these sort of hulls and then this higher res geometry, which is good. Cool. So the next thing I want to do is let's just poly reduce everything, even our concave stuff. Like our concave geometry, we're really not going to need like all of these polys. Like if we just generalize this to just maybe a couple triangles, I think we get away with quite a bit. So what I want to do is throw down another poly reduce at this point, but I don't want to poly reduce the whole thing all at once. I actually want to poly reduce each individual piece one at a time. So let's throw down a well, I'll throw down a for each loop. And we're going to use the preset for each named primitive. Since we've generated names already, we can just blast through all of these one at a time. I'll select a single pass and just kind of go through until I get to a point that looks like it's nice and until I get to a point that looks like it's nice. It's got a lot of you know, geometry to it. So let's just go up through. I'm gonna go into up until the point where we get to pieces that are part of our fine chunks, like so. For me, it looks like, yeah, there's just a ton of geo here. You can see it's part of the Boolean is in there, the shatter's in there, and also part of the VDB's in there. So yeah, piece 554 looks like a pretty good one to judge for me, and it's just all sorts of gnarly. And really, we don't need this much resolution to compute a good collision for this. We're really working with such a large number of pieces that a good approximation should do. So let's throw down a poly reduce, and we're just going to worry about poly reducing this one piece and see what we can get away with. So let's just bring this percentage down. So for the more I dial this down, you can see that it's reducing the polys, reducing them, and that's just, it reduces them until nothing. There's 0% left. I'm going to just set this to a value of 5. Well, let's go with 5%. Even though it creates this kind of weird shape out here, at the end of the day, all Bullet's going to do is take this and turn it into a convex hull anyway. So reducing everything to a value of 5 should be fine. Now, if I go and turn off single pass, it's going to take a little bit. It's going to think about it. It's going to run over all of these pieces and slowly poly reduce all 2,700 of them. You can see down here, it's gotten pretty far. Here we are. So now, what about pieces that are really, really super small? So I may have poly reduced more than I can handle. So if I go up here and middle mouse on our convex decomposition, well, what I'm going to do is I'm actually going to do an assemble up here. I'm going to do an assemble up here to just create pack geometry so that I can, and I'm going to turn off the name attribute because I've already got a name attribute. I just want to see how many pieces I have got. 2,712 here. And then I'm just going to throw another assemble down here to make sure that I haven't accidentally deleted anything, because reducing it too far will cause it to disappear. And you can see that these numbers are different. Down here it's 2,539, and we've accidentally deleted like roughly 150 of our points, which is no good. So what I need to do is figure out a way that I can get this to sort of limit the reduction of this poly reduce. So I think that the smallest size I'm willing to go is, if you look here, we've got some of these pieces, they look like they're approaching, looking like the size of a tetrahedron. So like maybe like this piece right here, for example. If I go here and select this piece, I'll just blast. So that, and then I'll blast this and say delete non-selected so we can look at just this one piece. This is an approximation of this piece right here. So I'm just turning off that poly reduce to see what this is an approximation of. Yeah, I think that something that is reduced to like, you know, just a tetrahedron. It's not like exactly the right shape. I mean, maybe we could do a little bit better than this. Maybe for our poly reduce, we can bring this up to like a value of 10%, and it's going to go through, it's going to run over all those points and kind of give us a more general shape. that fits the bill for that piece. So now if I go up here to our assemble, we have 2,712, and if I turn off this blast down here, still have 2,581. So let's say at the minimum, we need to have a polygon that has a piece of geometry that has 4 sides, or 4 polygons to it. So we can use another poly reduce. So I'm just going to option drag this one off, and instead of using a percentage of the input polygon count, we can use a output polygon count. And we can choose to set that to output only 4 polygons. So let's just wire that one in and see what we get when it runs over all those points. We get like extremely crude geometry, which is not what we want. We only want to do it for some points. So now that I have these 2 setups, what I can do is just switch between them depending on how many primitives are being generated by this point. So let's go and throw down a switch. And I'm just going to turn on manual mode for a moment because I don't want it updating while I'm working inside this loop. So I'm just going to wire this in here. And I want the first input to be wired to my original reducer, which reduces things down to 10%. So I'm just going to hit Shift R here to reverse those wires. And then here I'm just going to use a little expression. The expression is n prims. And n prims will just look at whatever input you give it. So I'm saying n prims of the 0th input. That's basically saying how many prims are in the 0th input. And I can set an if statement based off, or basically a Boolean logic off of this. So I can say number of prims. Number of prims is less than 4 for our tetrahedron, to create a tetrahedron. So it's going to say basically if the number of primitives is less than, in this input is less than 4, then it's going to evaluate to true and switch to the second input. So now let's see how many pieces we get at the end of our assemble. I'm going to switch this back on to auto update mode. So it's going to go through, it's going to reduce everything down to 10%. And if it sees that something at this point is less than 4 polygons, it's going to switch to the minimum of 4 polygons. All right, so I've got my assemble here. I middle mouse click on it, 2,712 pieces. Go up here, middle mouse click, 2,712 pieces. So we've successfully reduced everything down to its smallest possible size for maximum efficiency in our when we're doing our solve in Bullet. So now that we've generated these low res pieces for our simulation, we can I'm just going to put down a null so that I can make a note of that, of where we're at. So null, this null is going to be called low res pieces. And now we can actually use this assemble in practice. So I'm just going to wire this back in here because now when we go into our simulation, we don't want to rename it. We already established that we have a good name, but we just want to create packed geometry. So now this geometry is packed and ready to sim. I'm just going to throw down another null and call this low res pieces packed. And now what I can do is bring this into a rigid body simulation. All 2,700. It might run a little bit slow at first, but what we're going to do is we're going to glue all these pieces together so that we can keep the structure of this object and break it dynamically. But let's just go into creating a DOP.NET real quick. So I'm just gonna drag this over here so that now I'm just kind of banking this setup that we just did on the right hand side. I'm going to hop back out into the geometry level and just throw down a DOP network. So, and we're going to set this one up from scratch. So I'm just going to call this my RBD sim. And I'm also going to set this to be my fracture geo. And we're just going to jump inside here. Oops. I'm just going to jump inside here into the RBD sim, and we need a RBD packed object and a rigid body solver. And I'm just going to wire the RBD packed object into the left input of the rigid body solver and the bottom or the output of the rigid body solver into the output. I'll throw it on a gravity to keep just so that we can see something happening. And maybe also a ground plane. We'll just merge a ground plane in there. So let's throw it on a ground plane like so, and a merge node like so, and I'll just wire this guy in here, and there, like so. And the RBD packed object is not linked up to any geo yet, so the geo that we want to link it to are these low-res packed pieces. So we can simulate with these low-res pieces, but then take the transformation of these low-res pieces and use it to transform the other geometry, the high-res geometry. So I'm just going to grab this low-res pieces packed null and just drag it into the SOP path right here. And now if I go back to frame 1 and click play, nope, nothing happens. I got to be inside this. I got to select a node over here in order for it to like jump into this simulation. So now if I click play, it's going to think about it, and it is stepping forward our collision. You can see our statue is starting to fall into thousands of little pieces. I mean, and given that still it's not the fastest thing in the world, but given the fact that it's simulating close to 3,000 pieces, it's still pretty impressive that it's able to do it that fast, which is cool. So what we can do just to demonstrate where we're headed, this low-res geometry, it doesn't look like too fancy, but we can just use this new special node that was created pretty recently in Houdini. So over here in our fracture geo, I'm going to throw it on a transform pieces. This transform pieces node on the left hand side, it's looking for the geometry to transform, and then on the right hand side it's looking for the template points. Now because our geometry is all named appropriately, we've got a name attribute that was generated by this assemble, and it's flowing into our high res here. We can just bring this high res over. So I'm just gonna click on the output of that high res and just pop it into the first input on this geometry to transform. And then I also need to import my sim as well. So I'm just going to bring this up a little bit. And I just want to clean up this network a little bit. I don't need this other assemble. Let's get rid of that. I don't need this split. Let's keep the exploded view around. I'm just going to shake it off, have it handy. And I don't need this blast or this blast. And I don't like this wire crossing here, so I'm going to hold down the Alt key and click on it to bring a little elbow out. And yeah, we'll just I'll just leave that. Explode. I don't know what I'm doing with that. I'll just delete it. What am I doing? Cool. So let's just import this geo from our sim. So dop import. I'm just gonna wire this in right here. This is where the sim is happening, and our DOP network. We're gonna choose the RBD sim. Hit accept. And object mask. We're gonna put in our RBD packed object. And if I click on this, it is throwing an error. I think that's because I can't have this full-on file path here. I'm just gonna well, actually maybe I can have that. I'm just gonna say fetch geometry from dot network. Is that working? No. So I'm going to delete this file path. It just wants RBD packed object usually. So it doesn't necessarily work to drag this in there, but it's looking for this string so it can bring in that data back to us. So now if I wire this into the second point input and play back a little bit of this cache, you can see we get this high res fracturing happening based off of the positions of these low res points, which is really cool. Really handy little node because the fracture just looks gnarly. Let me just turn off the wire. I'm just going to put this on smooth shaded just so it's a little bit less distracting. You can see it's just so many little chunks all over the place, but and a nice little crack in the forehead too. But this is looking a little bit this is looking a little bit boring. I mean, it's just falling down. This is really where things start to get fun, where we put in our own constraints to get this to look, to get these pieces to hold together and fall apart in an interesting and fun way. So let's create some glue constraints. So why create any constraints at all? Really, we've kind of gone over this in one of the examples in our previous lesson where we were activating deactivated pieces. We could, say move some geometry that travels along our statue here and activates pieces as we go. But say when we got down here and all these pieces were activated, and we had like this large chunk of torso that was now floating, disconnected from pieces that have been fractured down here. Those deactivated pieces wouldn't move along with the rest of our sim. They would sort of be floating in space, and which isn't really what we want. We would like for these pieces to come along the arm, start crumbling away, and then like have the body remain largely intact until we get down here near the legs. And then when these pieces break, we want the rest of the body to come tumbling down as if it were one solid object. So in order to achieve something like that, as opposed to just using the activation attribute, we really want to use glue constraints. And the way we make glue constraints is we simply just add little primitives that connect all these pieces together. And it sounds complicated because we're using big words like constraint and small words like glue, but when in practice, it's actually quite easy. So let's just create some constraints here. Now, I'm going to spawn this off of the this assemble node right here, because this is where everything is packed and it's easy to create pieces based off of that. So I'm going to throw down a node called connect adjacent pieces. I'm going to just wire this in here and highlight it. You can see that it is trying to connect all of these little pieces together. And we're left with these little lines. Now, the search radius is kind of small, so I'm going to just increase that a little bit. It's not going to show any more connections because our max number of connections is only 1. So if I just start dialing this number up to something, I'm going to just middle mouse drag it up to something like maybe let's just do 10. So you can see that it sort of does like it does like a plexus like effect, where it's grabbing all these little pieces that we had over here and connecting them back together like so. And then, so the next thing that we need to do is we just need to create a constraint name. Now, what I'm going to do first is I'm going to throw down a null just so that we can have a nice point to grab from in our RBD sim. I'm going to call this constraints. And we'll come back and make the constraint name in a second. I just want to show you what really that actually is. So I'm going to just hop inside. I'm just going to hop over here into my DOP network, and I'm going to throw down a constraint network, like so. And I usually will just wire this in maybe above gravity. Doesn't matter, just as long as RBD packed object is flowing into it. So I'll just put this in here, and then you can see in the second input, it's looking for constraints to create. And the type of constraint that we want to create is glue. Glue basically means that it's going to look at these constraints and it gives us a sort of strength to work with, but it basically means that these constraints are going to remain pretty hard, just holding pieces rigidly in place until some force has pushed these pieces apart beyond this strength threshold, and then it'll break. So I'm going to just wire this into the second input, and if I go back here and click play, it isn't going to know what to do. It's just going to start simming the way it always was. Let's just go back, and I'm actually going to, in the constraint network, I gotta give it a SOP path. So that's going to be our constraint. So I'm just going to put that in there, and then now, if you look at this glue constraint, it says glue con rel here. This is where we set our strength and everything. It's looking for this data name thing called con rel glue. I guess for short for constraint relationship glue. So if I click play, still nothing's happening until I properly were to name these constraints based off of this data name. So I'm just going to do that really quickly. So I'm going to hit escape, stop the simulation, and then I'm going to go over here and create an attribute create. And if I just I'm just going to copy this data name right here. And then I'm just going to paste it over into this thing, but I'm going to set up, what I'm going to set up first is the type to be a string. And then I want my string to be this Conrel glue string. And I want to actually, I have to give it a specific attribute name. And this is constraint name. So constraint underscore name is what you want to name this, and then the DOP-net, this constraint network will actually know what to do with these constraints. One more thing I would need to do over here is I set this attribute create to a point class. I always forget to do this. It's actually a primitive class because we're dealing with a bunch of these constraints are all little primitives. These little lines are primitive. So I'm just going to change the class to primitive. So now when I go over here to the constraint network, you can see that it gives us this guide geometry that shows where all those glue pieces are. I'm just going to hit the D key and bring my point size down a little bit because it was creating those big black dots and it was a little bit distracting. So now you can see that based off of this guide color right here, we're able to see, or pick a color for visualizing our constraints. So I just set that to green, whatever. It doesn't really matter, but that's one way you can kind of visualize what's going on there. So I'm just going to turn the geometry back on for our actual simulation and click play, and we'll see what happens now. You can see that it all sort of acts as one piece, and it just falls over and remains glued together. Nice. So now this is all remaining glued together because on our glue constraint relationship under the data options tab, we've got a strength set to 10,000, and that's kind of that's high enough so that this isn't going to fall apart when it falls over. So maybe if we try to just lower this down to something like 10 and click play, we'll see what happens. You can see that the feet crumble, and then the upper torso starts to crumble, and then when it lands, it just shatters into a bunch of pieces. That's because we, reduced the strength of those glue pieces. And then other important things to note are just these other features up here. Half-life. This basically, this half-life and propagation rate and propagation iterations are going to sort of control how forces move through the constraints. So like if a force is applied here, it will kind of propagate through the geometry and continuously break chains in terms of like a almost like a domino reaction or something, or chain reaction, something like that. So that's sort of what these controls do. And if you middle mouse hover over it, you can see this specifies how much impacts propagate along each glued bond in a constraint network. So that's propagation rate of 1. That's probably means that it's going to propagate those impact forces at faster rate. And the half-life is this would determine how it looks like the number of seconds for glue impulse to decay by 1/2. So basically that means if an impulse is traveling through here, it will eventually die off on its own based off of how quick of a half-life it is provided up here. Cool. So the other thing I want to do right now is I don't want this statue just to fall over right away. And, I know that the base of this pedestal is pretty flat, so I'm not quite sure why it's tipping over, but I think it might have something to do with our collision hulls. So let's just take a look at those real quick. I'm going to go over here to the RBD packed object and go to the bullet data tab and then just show guide geometry. You can see that we've got some convex hulls here. You can see that they're kind of in crazy shapes. Now, we did that convex decomposition before, and so we should actually be able to get a higher resolution or more accurate collision hull if we turn on this create convex hull per set of connected primitives. So I'm just going to click this box. You can see that now all these this guide geometry adheres much more closely to the surface. Another setting that I want to tweak, if I just come down here a little bit, is this collision padding. You can see that some of these chunks are kind of sticking out from the surface, and I really want them to adhere to their original shapes a little bit better. So what I can do is if I just dial this back down, you can see that all these pieces get much closer to their original shapes that we were inputting. So I'm using a value of about a 0.005. That seems to have a bunch of shapes that are really close to the input, which is good. And now it looks like that should have made the floor, this bottom part of the pedestal, nice and flat. So we'll see if it stands up on its own. But if it doesn't, and what I'll probably do anyways, because when we start applying forces, it would knock this over. I'll just deactivate the lower part of this so that we don't have it falling over. So I'm going to untick create I'm going to leave create convex hull on. I just want to turn off my show guide geometry, and then I'm just going to hit play again. And those glue constraints are not strong enough to keep this figure in place, so it is falling and breaking apart gloriously. But I mean, it's doing what it's supposed to do, but I just want to lock down these feet. So let's just go back over to our fractured geo setup here. And if I just insert some stuff above this low res pieces packed null, it should filter through to the sim. So what I want to do to deactivate these pieces near the floor is I want to use the active attribute like we did in our previous example. And so I need to kind of initialize that active attribute to a value, because I generally want all the pieces to be active. I'm going to initialize it to be all the pieces to be active, and then use a group to deactivate a certain number of them. So let's do an attribute create. And in here, let's throw this guy down, and then I will put, let's just bring this back over like that. I'm going to put down this name is going to be active, and it is an integer attribute, and it's going to have a value of 1 because I want all the pieces to be active unless I specify otherwise. So going down below this, then I'll create a group. And this is going to be a point group because when we're working in this way, we can, I just find it easier to work with points, and it allows me to select my packed primitives as if they were points, just based off of where their centroids are located. So I'm going to call this the inactive group. And it's gonna, I'm not gonna use a base group. I just want to use a bounding region. And so I'm just gonna, the bounding box is pretty close to where I want it actually, but I'm just gonna bring it down a little bit so we get something like this. You can see these slightly highlighted in green pieces. So it looks like I've got enough fracture where I'll have like, these two legs kind of standing. They're not perfectly even. Yeah, that looks good to me. So now that I've got this group that's called inactive, let's just do something with it. So I'm going to use a point. This point SOP will allow me just to set an attribute on my own. I could do this using VOP as well, but just for the sake of shaking things up, let's just use this guy right here. So I'm going to yes, we're going to use a point. This is a point class, obviously. We're going to use a custom attribute, and the custom attribute is going to be active, and it is a type integer, and we want to set it. So I'm going to say set it to a constant value, and that constant value is going to be 0. So these pieces down here should be inactive now. So if I go and select my group and sort down in my geometry spreadsheet, I'm going to sort this by the group inactive. You can see that wherever this 1 is means that we have a group that is in the inactive state. So most of them are active except for these. And you can see that their active attribute is set to 0, and all the rest are also set to 0. What's going on with that? Well, I didn't specify this group up here. So this point is actually operating on all the pieces and setting all of their values to 0. So I just need to go up here and specify I only want to modify the inactive group. So now all of our pieces are activated when they're not in the group. So this is 0, this is 1. And then when we go back up to the top, active is 0 when it's in the group. So that's exactly what we're looking for. Now, if I go back over to our sim, I'm just going to bring this down a little bit. If I go back over to our sim and click play, the statue should do literally nothing. It should just sit there and be totally chill. Nothing's happening with its constraints. Everything is good. So the next thing I want to do is I want to create some, I want to create a little, a way of bringing, of breaking these glue constraints and applying some forces to it. So we did that, we built that curve so that we could kind of like define where we wanted our forces to go. So let's go and play around with that. Just gonna let's just go back up here to the fractured geo. I'm actually gonna put over here my RBD sim, so I can sims over on the right now, and our big fracturing setup is on the left.